Hello students, how are you all doing at home? Welcome to Berry Learning for Jss2 class, Mathematics Jss2 class. Where we look at the topic angles of elevation and depression. Angles of elevation and depression. Before we went back for holiday, we treated angle as a topic, and we were told that angle is formed when two lines meet. So an angle is formed where two lines meet. We have two lines at this point forming an angle theta. At this point, we look at angles of elevation and depression. Before we go into looking at this topic, angles of elevation and depression, we look at what a plane is. What is a plane? A plane is a completely flat surface. Any surface that is completely flat is referred to as a plane. For instance, the floor of your classroom is a plane because it's a completely flat surface. We have two types of plane. We have the vertical plane and the horizontal plane. The vertical plane and the horizontal plane. For the horizontal plane, it is formed parallel to the flat surface. The horizontal plane is any plane that is parallel to the surface of the ground. The horizontal plane is the plane that is formed parallel to the surface of the ground. For example, we have the surface of a table. It's an example of a horizontal plane. While the vertical plane is formed perpendicular to the surface of the ground. For example, we have the walls of our buildings is perpendicular at 90 degrees to the surface of the ground. So we say it's a vertical plane. Now we look at the angles of elevation and angles of depression. An angle of elevation is the angle formed between the normal eye level, which is called the horizontal plane, and the object above it. The angle of elevation is an angle formed between the normal eye level and the object formed above it. While the angle of depression, we say, is the angle formed between the normal eye level and the object beneath. We look at the relationship between these angles of elevation and angles of depression. But before we do that, we use the illustrations to explain the differences between angles of elevation and angles of depression. And we see differences between the angles of elevation and angles of depression. Now let's assume we have a student which is some meters away from the school flag. We have a student who is some meters away from the school flag. Now, this is the horizontal plane because it's formed parallel to the surface of the ground, and we call this the eye level of the student. And if he decides to view the top of the school flag, he raises his head up. There is a head movement upwards. So an angle is formed here as he views the top of the school flag. Now this angle formed between his normal eye level and the object or the tip of the flag is called the angle of elevation. The angle formed between the student's eye level and the top of the school flag is referred to as angle of elevation. Also, we give an illustration to explain angle of depression. We have a student viewing another student downwards. Now, this student is at the upper platform viewing the students down. This horizontal plane is referred to as the student's eye level. But if he decides to view this other student downwards, there is a head movement and he views below the eye level. He views below the eye level. The angle formed between the horizontal plane and the other student beneath is called the angle of depression. While this other student, this is his normal eye level, and for him to see this other student above, he decides to move his head upwards and the angle formed between its normal eye level or horizontal plane and this other straight above is called the angle of elevation. It has been proven that angle of elevation is always equal to angle of depression because we are told, I told you previously before the holiday that alternate angles are equal. Alternate angles are equal. So our angle of elevation is alternate to the angle of depression. So our angle of elevation is the same as angle of depression. Now the figure on the board shows two students, Adu and Chinedu. Adu, as you can see, is on the higher platform and Chinedu is on the lower platform. You can see that Adu moving this way, this is the horizontal plane, otherwise called his eye level, because that's the way his eye is facing. Now, here facing the other way, you can see his normal eye level here, which is also his horizontal plane. For this to communicate, there has to be a head movement between its normal eye level or horizontal plane and downwards. This angle formed between its horizontal plane and its movement, its head movement downwards is called angle of depression. On the other hand, for Chinedu, the angle formed between its normal eye level and looking at Adu upwards is known as the angle of elevation. And this is the relationship between angle of elevation and angle of depression. As I said, both angles are alternate and we say they are equal. Look at calculating heights and distances. Calculating heights and distances using scale drawing. Calculating heights and distances using scale drawing. We have an example. The figure below is a sketch of a student standing at the end of the classroom building. You observe that the angle of elevation of the top of the classroom is 39 degrees. Using the data provided on the sketch, find the height of the building using a scale of 1 cm to represent 8 meters. So we'll sketch the building. We have a student. The figure below is a sketch of a student standing at the end of a classroom building. We have the student at the classroom building. He observed that the angle of elevation of the top of the classroom is 39 degrees. The angle of elevation of the top, we have the top of the classroom here to 39 degrees, and this is the student's eye level. 39 degrees. You have to use the data provided on the sketch to find the height of the building using a scale of 1 cm to represent 8 meters. Now, from our scale, what it means is that for each 1 cm we draw on the board to give us 8 meters in real life. For each 1 cm of any of these objects to be 8 meters for the actual length. So, we have to find the height of the building using this scale. Our scale is 1 centimeter to represent 8 meters. So we start with the actual size or the actual value. From the question, we are told that the student's height is 1.6 meters. So we write student's height is 1.6 meters. The distance between the student and the classroom. The distance between the students and the classroom. We have the student and the classroom. The distance here is 34.4 meters. 34.4 meters. Now, all this we say is the actual value, that's the real size of this student and the distance between the student and the classroom. We will now look at the length on drawing from our scale. And I told us that from each 1 cm we draw on the board, it was 8 meters of the actual value. So we now look at the length on drawing. So for us to do that, the student height we are told is 1.6 meters. So the length on drawing, since the student height is 1.6 meters, for us to get the size on the board, that's the length on the board. We now say from our scale, we have student's height to be 1/8 from our scale, 1/8 times 1.6 in cm. This is looking for the length of the drawing. This 1.6 meters is the actual length of the student. We are now looking for the length on the board using this scale. I say for each 1 cm on the board should represent 8 meters on the actual value. So we say 1/8 times 1.6. And if you do that, 8 into itself is 1, 8 into 1.6 equals 0.2. So we have the student height to be 0.2 cm on the board. That means for 1.6 meters of the real size, which is the real size of the student, to give us 0.2 cm on the board. So that is the length or the student's height for length on drawing. Now we look at the distance between the student and the classroom. Distance between the student and the classroom. The distance between the student and the classroom. From our actual size, the distance between the student and the classroom is 34.4 meters. So we apply this scale again to get our length of the drawing. We say 1/8 times 34.4. 1/8 times 34.4. All is cm. This will give us 34.4 all over 8, all in cm. If we divide this, we get 4.3 cm. So the distance between the student and the building for our length of drawing gives us 4.3 cm. That means 4.3 cm on the board should give us the actual value of 34.4 meters. The distance between the student and the classroom. From our diagram, here our 34.4 is now 4.3 cm. So here we now have our length of drawing. We have 4.3 cm. Here it becomes 0.2 cm. Our 39 degree remains constant. Between the eye level and the tip of the house, we call it the height. Okay, now from our SOHCAHTOA, we use tangent. We are finding, say, tan 39 degrees will give us opposite over adjacent. Opposite all over adjacent. So we say from the diagram, tan 39 degrees give us h all over 4.3. Remember our opposite is h, while our adjacent goes 4.3. Because since we have this part to be 4.3, this side is opposite and equal to this, so we still have 4.3 here. So we have h all over 4.3. At this point, we cross multiply to get h is equal to tan 39 degrees times 4.3. Tan 39 degrees times 4.3. We use our mathematical table to get tan 39 degrees. We have 0.8098 multiplied by 4.3. Multiply by 4.3. We multiply that, we get 3.48 cm as our height of the building. Our height of the building is 3.48 cm. Let me run through it again from the question. We have here, the figure below is a sketch of a student standing at the end of the classroom. We have the student standing at the end of the classroom. We say, he observed that the angle of elevation of the top of the classroom is 39 degrees. See the student's normal eye level, and he looks at the top of the classroom. And the angle formed is 39 degrees. So we call it the angle of elevation. You say the angle of elevation is 39 degrees. You say using the data provided on the sketch, find the height of the building. Using the scale of 1 cm is to represent 8 meters. Using the scale of 1 cm is to represent 8 meters. And I told us that for each 1 cm we draw on the board to give us 8 meters of the actual size of the object. For each 1 cm on the board should represent 8 meters of the actual size. So the length of the student is 1.6 meters. If you have the length of the student to be 1.6 meters, and our scale, remember, is 1 cm to represent 8 meters. For us to get the length on the board, we say 1 over 8 times 1.6, all is cm. 1 over 8 times 1.6. 8 into itself is 1, 8 into 1.6 equals 0.2. So 0.2 cm is now the student's height on the board. using our scale. So we have 0.2 cm now as the length of the student or the height of the student on the board. Also from the question, we were told that the distance between the student and the classroom is 4.3 meters. Sorry, 34.4 meters. But for length of drawing, we can still apply our scale. 1 cm is to represent 8 meters. So we see 1/8 times 34.4. If we divide that, 34.4 over 8 equals 4.3 cm. So the length on drawing, the length on the board, the distance between the student and the classroom gives us 4.3 cm. As after doing that, we say from the diagram, we are now looking for height, the height of the building. The height of the building is given as tan 39 degrees equal to opposite all over adjacent. Opposite all over adjacent from SOHCAHTOA. From SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So having said that, tangent is opposite over adjacent. So tangent of 39 degrees gives us opposite all over hypotenuse. So the opposite is not given. So we say tan 39 is h over 4.3. From this body that is saying all over 1, we cross multiply. Our h will give us tan 39 times 4.3. From our 4-figure table, tan 39 degrees will give us 0.8098. Multiply by 4.3. And that gives us 3.48 cm. Now remember that the student height, the upper side of 1.6 meters, but the length on drawing is 0.2. So we add this to 3.48, and that gives us 3.68 cm. So the actual height on the board gives us 3.68 cm, but the height, the actual size of the building, the actual height of the building multiplied now by 8 from our scale, which says that 1 cm represents 8 meters. So for us to get the actual height of the building, we now multiply this by 8 in meters now. We multiply this by 8 to give us 29.44 meters. So the actual height of the school building gives us 29.44 meters.